Hello, I'm Ricard Vilalta, Senior Researcher at CTC and TeraFlow Project Manager. And today I would like to introduce this project to this special session on autonomous network management towards 6G. TeraFlow is following the trends that we have that we will have with 6G. There will be a lot of data flows, lots of data. We will also have some more attacks, malicious attacks increase. In this case, we assume the trends that we have demand for richer user experience, more focus on data and the user protection. We will growth. We need services which will demand better connectivity. We will have heterogeneous distributed service provider environments. This will increase also the user equipments in the networks, as many user equipments will not be users. It will be cars, connected things, and so on. And we will have an increased need for dynamicity of the advanced service. So this leads on the stakeholders that we are addressing, the different end users, access operators and transport operators, hyperscale cloud providers, policy makers, blockchain entities, SDN providers. We see pains in the current ecosystem, and we see pains in the business ecosystem. So this slide tries to summarize both and motivate the different innovations that we will have in TeraFlow. If we check for the pains that we have in the current business ecosystem, we can see that, for example, we cannot prioritize the use cases. We have limited from moderated whole network vision. We have a sharing process that ends in resource starvation. We have transport slices that don't get the desired QoS. So slice isolation is an important topic. We cannot deal with this massive number of requests. So I always talk about the cloud scale. We need to be able to handle connectivity requests as number of Google searches per second. So this is the cloud scale that I'm thinking always. For that, we need to have this compute network integration and overview for the edge to core. These are the pains. So we have a lot of high energy consumption, one-to-one relationship on resources and tenants, and so on. So this is the business ecosystem, and we anticipate the pains on the right side for the future business ecosystem, and such as administer higher volume of complex contracts and transactions, validate allocated resources, provide beyond 5G network with multiple administrative operation business support services, follow me, support follow me and context-aware flows, increased, and we will have more network threats. We will have ledger scalability issues, ledger trustworthy issues, and how this is integrated in the network management. And finally, we will need also the challenge to support and audit and verify the transactions. So for this, we see the TeraFlow contributions. To fix these pains, you can see that the main contributions for TeraFlow are the transport network integration, the unification of network and resource management, then the cloud native architecture. That's one of the key contributions of TeraFlow. Then machine learning-based security, and the introduction of distributed ledger topologies in the SDN controller. The architecture that we are proposing, this is a preliminary architecture. Of course, it will be modified during the next year. But this is the overall view. So we can see that we focus on an SDN controller. We want to do one thing right. And in this sense, what we envision is the cloud scale of this SDN controller. You can see that each component that we are presenting is a microservice, which interacts with the other components through this integration fabric, bus, and so on. This is how microservice architectures work. So you can see that we have several components identified, such as the context manager or the device manager, the monitoring tools, the automation and policy component, the compute component, the DLT component, service component, and slice component. These are basically the core TeraFlow applications, microservices, and then we have also some other microservices such that allow load balancing, auto-scaling, self-healing, for example, and also some of them that provide cybersecurity and inter-domain connectivity. So that's we don't want this isolated, so we need to relate this TeraFlow SDN controller with the outside world towards the operation support system and the business support system of the operator, and also towards other manus that might be available in the system. So that's the overall architecture. We are planning to support different underlying networks, such as microwave networks, for example. We are also supporting standard optical networks. We are also planning to introduce support for P4, for example. And then at the IP layer, we are also introducing some routers that will be configured using OpenConfig, for example. So this is our view of architecture in TeraFlow. So we have presented the architecture that we are proposing for TeraFlow. And in this slide, this is the first slide of scenarios. We present two different scenarios today. One focused on the beyond 5G networks, another one focused on inter-domain connectivity. In this case, we focus on the beyond 5G networks. I always say that this is the operator scenario, where we want to demonstrate the power of using TeraFlow inside an operator network, so the operator can validate completely how TeraFlow is working for the transport network. So in this case, you can observe the different technological domains. So we have an optical network, we have a microwave network, we have P4 routers, we have also then the IP layer with IP and PLS network with physical devices and virtual devices. So we have Infinera on the project for the physical IP routers. We have Volta networks for the virtual IP devices. We have also CI, for example, who is providing microwave network. We have Telefonica network equipment from the Future Network Lab. And we have UBTech supporting us on the P4 node. So in this case, we want to trigger a slice model that's available, that is capable of exporting the underlying capacities of the different technological domains. In this case, if we want, for example, to request some slice of isolated, we can provide some specific details on the different technological domains that provide the level of required slice isolation. For example, a hard slice allows a lot of isolation in the infrastructure. So this means, for example, to have a dedicated lambda for the requested slice, or a specific spectrum slot or time slot if we are exploring different switching techniques. Also, it might refer to having a dedicated virtual router on a specific server, or to have dedicated IP routers. So these are the kind of things that we want to explore. We are also playing with different protocols. In this slide, you can see that we are planning to use ONF microwave models. Also, we are planning to use IATF network slicing young data models. We are also planning to use ONF transport API for the optical domains. So these are all the different protocols that we can envision in this architecture. And the objective is clear. So we are following a pragmatic approach to leverage operator-driven workflows, such as the ones I commented of transport network slices and layer 2, layer 3 services. We'll focus on delivering these implementation guides using standard interfaces and contributing to the community with some gap analysis. So in this case, you can see that the data rate is one of the significant KPIs. We want to have a multi-layer optimization, introduction of optical layer closer to the edge, and also the inclusion of different novel optical technologies, such as SDM, Flex Ethernet, or disaggregated FlexiGrid. So the idea is that we're able to provide this multi-technological approach that I was commenting in the previous slide. Also another significant KPI for this scenario is the latency. So we will have the delay budget computation, including traffic offloading mechanisms to the optical layer. So optical layer is the faster in latency terms, so that we can have some kind of delay budget computation in order to achieve an increase of the efficiency of the system and decreasing the latency. Also, we want to focus on energy consumption. We have multi-layer optimization, and this leads to a reduction of this energy consumption. And finally, also the economic. So we want to reduce both in the CapEx and in the OpEx. So we are in a disaggregated network model. So we can reduce this cost through this disaggregation. And also we can reduce the cost through the different OpEx automation. If we take a look at the interdomain scenario, we can see that it will be demonstrated at CATC premises in the Adrenaline platform, which combines SDN NFV, Packet Optical Transport Network, and an Edge-core cloud platform. We are interested in testing end-to-end 5G and intelligent transport system services, which include competitive awareness messages, decentralized environmental notification messages. So we are looking at a V2X scenario at the edge, and then we want to experiment on how the core and the transport and the core can relate to and adapt to this huge number of flows that will be needed. So we have this interdomain where we will also experiment with two different TeraFlow OS domains, which will interact maybe using the DLT technologies that we are researching in TeraFlow. So that's one of the most interesting points of this scenario. We have the objective in this slide. So as I was commenting, we want a huge scale and diversity of CAMS services, imposed three main requirements for the transport services: low latency, high capacity, and massive flow management. That comes the name of TeraFlow. So we need to handle a tera of flows. And then the proposed multi-domain scenario, per domain connections will be needed to interconnect and in order to compose multiple end-to-end connectivities across different domains. That's the second part I was commenting. Then the KPIs that we will be evaluating in this scenario are the resource efficiency, where we will be making measurements, resources needed to serve a given traffic request with and without using integrated resource orchestration. We want also to have multi-tenancy, as trace this slice management system I was commenting before, and measure the allocated slices. And then we have the latency. So we want to measure the delays with using this budget delay computation I was referring before in my previous slides, and include the trust privacy. So we have 100% of secure connections, and then deployment of secured communications, positioning. Also, we might be able to deploy position-based techniques for all the vehicles, and also social. So we can have a reduction of OpEx network for this scenario. So thank you very much for attending this session. I hope that you have fulfilled all your interest in TeraFlow. We are expecting to release the first release of the software by end of this year. If you want more information of TeraFlow, you can go to the regular paper that focuses more on the different architecture that we're proposing, and the workshop 8, which focuses on security. So I hope that this fills your interest on the topic and that you enjoy it. In case that you had more questions, you can follow us on our social media, and thank you very much.